Hey, Miss Marion here. Let's turn to page 112. Just so you know, we're going to be doing lesson 6 and lesson 7 today, squished together. So the first I can statement is I can use the slope of a line to fit to data in a scatter plot to say how the variables are connected in real world situations. Go ahead and write yourself a sentence. Give yourself a number. 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. Staying on that page, actually turn to page 113, and we're going to do 2 I can statements for lesson 7. I can pick out clusters and data from a scatter plot, and I can use a scatter plot to decide if two variables have a linear association. Again, go and write yourself a sentence, give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. So let's go ahead and start out on page 55. We have this graph here, and we're going to estimate our slope. So we're going to get something very, very close to it. We're estimating it. Go ahead and pause, figure out what that slope is, and then come back to me. So a couple of units ago, we were doing slopes. We were figuring out what the slopes were. And what I'm going to do is I'm going to use these 2 points because they're very, very close to the line to go ahead and find our slope triangle. So remember, we have our vertical and we have our horizontal. So remember, our slope is our vertical over horizontal. And what I want to do is I want to figure out what this vertical is. And so we start at -6 and we go up to 2. So here, from here to here is 6 steps, and then I have 2 more steps. So that vertical is 8. So that's what our top is 8. Then I want to figure out my horizontal. So my horizontal, if you look at it, it goes from -4 all the way up to 5. So from here to the y-axis is 4, and then from here to here is 5. So that will make it 9. So my slope is 8 over 9. So to help us with our next activity, what we're going to do is we're going to look at this graph, this scatter plot with a line to best fit. And how would you describe the relationship between the weight and the fuel efficiency? So we're going to kind of play with the slopes and put it in verbally what's going on in that real world situation. So think about it for a second. This is not in your book. Just think about it for a second, what's going on in this graph, and then come back to me. So what we can do is we can say, okay, as the weight increases, the fuel efficiency decreases. So let me say that one more time. As the weight increases, our fuel efficiency decreases, or it goes down. So this is what we're going to kind of go ahead and do in our next couple of pictures. So let's look at page 56. And so I kind of give you some sentence frames to go ahead and go along with this. And it says, for this data, as blank increases, blank tends to increase. For this data, as blank increases, blank tends to decrease. And for this data, blank and blank do not appear to be related. So what we're going to do is pretty much put those labels in there. So if we look at this is kind of the same question that we were looking at. As the weight increases, the fuel efficiency tends to decrease. So let's go ahead and fill that in. And that's what we'll actually go ahead and say. For this data, as the weight, we say in kilograms, increases, the fuel efficiency tends to decrease. All right, let's go ahead and turn to page 56, and let's look at this graph here. So let's go ahead and fill in one of the sentence frames that goes ahead and goes along with this information, and then come back to me. So our answer should be, for this data, as mileage increases, the price tends to decrease. All right, this one is on page 57. Again, we're going to go ahead and fill in one of the sentence frames that goes along with the information itself. So pause, fill in that in, and write it next to the graph on your page 57, and then come back to me. So we can say, for this data, as the weight increases, the price tends to increase. All right, here's another one on page 57. Go ahead and fill in one of the sentence frames goes along with this information. So pause, fill that in, write it next to the graph, and then come back to me. So the sentence that you should have had is, for this data, as the daily high temperatures increase, energy consumption tend to increase. So we've been looking at different slopes and how it looks at as far as the scatter plot, and then if we had a line that best fit with it, what it will actually go ahead and see. And so some of the stuff we tend to increase as the stuff increases. As notice how the bottom of the independent variable is always increasing, and then the dependent variable is either increasing or decreasing depending on the information. So this one down here will always increase. So let's look at slopes again. And so here we have a picture, and the equation is y equals negative 0.0073x plus 17,404.485. So this is our equation that goes along with this graph. So a couple of things that we need to remember are the equations. And so remember that the first one is our slope, and the second one is our y-intercept of our equation. So the first one we get the slope information, and then the second one we can kind of see where it starts and where it starts from. And so what we want to do is we want to kind of sit there and think about, okay, what does the slope tell us, and what does it give us, like what does it tell us about here? So I want you to think for a second, and then I'll come back to me. So this slope, what it tells us is that the price is going to go down 0.0073 cents per every year. And so that kind of tells us that the price, this is probably price of a car, because it's negative, that means as the mileage goes up, our price is going to go ahead and go down. So it's actually $0.0073 per every mile it actually has on the car. All right, so we're going to use that last graph that we had with the slope, and then we know what our slope and our y-intercept is. And we're going to fill in the sentence frame to go ahead and help us describe what the slope is going on. So, I'm going to go ahead and let you do that. So go ahead and pause, fill that in, and then come back to us. All right, so we have it as the slope is negative 0.0073. If the mileage increases by 1 mile, the model predicts that the price decreases by $0.0073 per mile. All right, here is number 2. So go ahead and fill in the information, find your slope, fill in the information, and then let's talk about what is going on with the scatter plot and the line. So we have the slope is 5,520.619. If the weight increases by 1 carat, the model predicts that the price increases by $5,520.619 per carat. Here is example number 2. Go ahead and figure out your slope and your information about the slope, and then come back to me. So we have the slope is negative 0.011. If the weight increases by 1 kilogram, the model predicts that the fuel efficiency decreases by 0.011 miles per gallon per kilogram. All right, our last example on page 57. Go ahead and find the slope, and then figure out what the slope actually means, and then come back to me. So the slope is 0.59. If the high temperature increases by 1 degree Fahrenheit, the model predicts that the energy consumed increases by 0.59 kilowatts per 1 degree Fahrenheit. So now, since we've been talking about the slopes of scatter plots and how they are, let's go ahead and remind ourselves about the association. So what kind of association is this? Is this positive or negative? Go ahead and answer, or no association. Go ahead and answer that question and then come back to me. This association is a negative association. All the information is going down the hill, so it's negative association or correlation. What kind of association is this one? Positive, negative, no? Then come back to me. This is a positive association or correlation because it's going up the hill. Is this positive, negative, or no? Go ahead and come back to me. This is a negative correlation because all the information is going down the hill, so negative association or correlation. All right, is this positive, negative, or no association? Go ahead and answer that and come back to me. This is considered no association or no correlation because you can't really put a line on here as far as where all the data stuff is clumped together, either going up the hill or clumped together going down the hill. So this is considered no association. Positive, negative, or no? Go ahead and come back to me. This is considered positive. If you look at it, you might consider it no, but it's actually positive because you can actually go ahead and put a line through all the information and it's going up the hill. So this is a positive association or correlation. All right, let's go ahead and go into lesson 7. On page 67, here is a scatter plot. Write down one thing that you notice and one thing that you wonder, and then come back to me. So a couple of things you can do. I noticed that the points are not all on the same line. I noticed as the production increases, the price decreases. A couple of things you can wonder. What does the oil production or import prices mean? I wonder, is it okay to model this relationship using a line? What does it seem to level out at the end? Why does it do that? So we're going to kind of talk about all of this today in this lesson as far as lesson 7. All right, so we're going to answer 2 things. Is this a positive or negative association or no association? This is considered a no association because note how it kind of goes up and then it goes down. So this is no association. And is this linear or nonlinear? Remember, linear means that we can make a straight line. Okay, so can we make a straight line with this? No, this is considered nonlinear. All right, positive, negative, or no association, linear or nonlinear. Go ahead and answer those 2 things. All right, so this is considered a negative association because all the stuff is going down the hill. And is this linear or nonlinear? This is, all right, positive, negative, or no association, linear or nonlinear. All right, this is considered a negative association. And it's also considered linear because we can put a line through the information. Positive, negative, or no, linear or nonlinear. Is this negative? Information is going down the hill. What kind is it, linear or nonlinear? This is considered nonlinear. Positive, negative, or no, and then linear or nonlinear. So this is negative because it's going down the hill, and this is linear because you can put a line, a straight line through all of it. Positive, negative, or no, linear or nonlinear. This is a positive association. Okay. And then as far as linear or nonlinear, this is nonlinear. Because if you kind of put it through all the information, it kind of curves. Positive, negative, or no, linear or nonlinear. This is a positive association. And then this is also considered nonlinear. All right, positive, negative, or no, linear or nonlinear. This is considered no association because it kind of goes up and down. And then this is linear or nonlinear. This is nonlinear. All right, let's go ahead and turn to page 69. We're going to talk about clustering a little bit. How are these scatter plots alike, and then how are they different? Go ahead and answer it, and you're going to answer it for all 4 questions. Go ahead and write it on the sides of the graphs. How are they like, and then how are they different? All right, we can say that graph A and graph D, they're both negative association. But graph D, comparing these 2, this one has like a gap that's in there. So B and D have like 2 sets. This one has a split set that's also in there. A is different from all the rest because it has just kind of one big chunk. Okay. And what we're doing is we're talking about is called clustering. See how these are kind of clustered together? and then these are clustered together. So there's certain times when there's clustering. Clustering is also where we have like a gap that's in the middle of it. And so sometimes when we do scatter plots, we see a cluster. We see that all of this information is kind of either on one side or another, or it's split in between the two. And it kind of gives us a lot of pieces of information. So notice today how we're talking about scatter plots and graphs and slopes and how they change. Also, if they're clustered or not clustered. We also talked about positive association, negative association, and then we put in that linear or non-linear association along with it. So let's go ahead and let's turn back to the I can statements. Remember, we're doing 2 lessons. Lesson 6 is I can use the slope of a line fit to data in a scatter plot to say how the variables are connected to real world situations. I can pick out clusters in a data from a scatter plot. I can use a scatter plot to decide if 2 variables have a linear association. These are all 3 I can statements that we're talking about today. Go ahead and give yourself a sentence for all 3 of those. Also give yourself a number. 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And then 4, I can teach it to my friend. Remember, we are doing 2 practice problems for today. Make sure you get both practice problem 6 and practice problem 7 done for today. Have a good day. Thanks.